I think this is the same type of question. A closed cylindrical tank, total surface area of 18 pi. Find the radius for the largest volume. So it is the optimization of volume, that's all. You want to optimize the volume. So your target must be something like this, equal to 0. That will give the value of this variable. That's all. Very easy. The same type of question. But I want to explain, I want to fix the method of optimization in your brain. So let me do it. A closed tank, cylindrical tank, has the total surface area of 18 pi. Total surface area, I use the symbol A, that is 18 pi square meter. Total surface area is 2 pi RH. In the formula sheet, I just checked. They have given only this formula for the curved surface. But as we are discussing the closed cylinder, you have to include the top and bottom. Fine. Now, we want to optimize the volume of cylinder, so I have to write it over here. V is pi r square h. But here we have two variables in front of V. So I have to eliminate one variable out of these two. But I do not prefer to eliminate r, because from here to obtain the r is equal to something is a real difficult task, because see, basically this is a quadratic in r. You will not be isolate r over here, but you can easily obtain this h in terms of r. So let us do that. 2 pi RH is equal to 18 pi minus 2 pi r square. So h is equal to 18 pi minus 2 pi r square over 2 pi r. So you can take this 2 pi common and cancel. You can do that. Let us simplify this. It is always advisable to simplify this. So 2 pi is common. So we get 9 minus r square over 2 pi r. 2 pi cancel. So h is 9 minus r square over r. That is my first result. Now I can plug in this value of h over here. So h will be eliminated. V is pi r square, and value of h is 9 minus r square over r. These are cancelled. So I get V is equal to pi r 9 minus r square. We can multiply this pi r in the bracket. So we get 9 pi r minus pi r cube. So now V is purely the function of radius. So we can differentiate V with respect to r. Let us do it. You know the differentiation process. You should try it. So the differentiation of 9 pi r is 9 pi, and here it is 3 pi r square. Good. Now we want to optimize the volume. So what we write? For the maximum or minimum value of the first derivative has to be 0. So that is 9 pi minus 3 pi r square is equal to 0. It is 0. So I can obtain r from here. 3 pi r square is equal to 9 pi. So r square is 3. So I am getting r is equal to plus or minus root 3. But seeing the physical situation, the appropriate answer is r is equal to root 3. So when the radius of the cylinder is root 3, it will have the maximum volume. That's all. You can write the unit if you want, meters. And here they are saying that you do not have to prove that your solution gives the maximum volume. So just accept it, that be happy. This is giving the maximum volume of the cylinder. That's fine. If you want to find that maximum volume, the task is very easy. Use this r over here. You will get that maximum volume. And when the volume is maximum, at that time, what will be the height of that cylinder? You can use r over here. You will get that height of the cylinder. That gives the maximum volume. So we need not to go for the second derivative test over here because they are not expecting it from us. So why should we waste our time? And if they are expecting, then I have explained what is to be done. Go for the second derivative test. Okay. Here, volume is given to us. Fine. And we want to find the radius in the situation that the surface area is as minimum as possible. If you want to try this, you will be very happy. Here I am explaining. Volume is given. So volume of cylinder and that is 50 pi cubic meter. And we have the formula of that. Pi r square h is 50 pi. Pi cancel if you want. So you have r square h is equal to 50. Please keep patience. What you want to optimize? You want to optimize the total surface area. So I will write the formula over here. The total surface area is 2 pi r h plus 2 pi r square. This is the total surface area. So I have to differentiate this a with respect to r. And see why I am keeping r in our discussion. That is very, very, very important. They want you to find r. So if you will eliminate r, you will not get r, you will get h. And then at the end again you have to put h somewhere and you have to get the value of r. So what I am manipulating over here, that we want r. So I am keeping this r in the discussion. I am not eliminating r. I am eliminating h. I am keeping r in the discussion so I can get the direct answer. So let us eliminate this h. So h is equal to 50 over r square. Good. 2 pi r 50 over r square plus 2 pi r square. These r and these r cancelled. So I have 100 pi by r plus 2 pi r square. So now I can differentiate this a with respect to r. It is an easy task. Let us do it. There is only one variable in front of a, and that is r. I can say that a is the function of r. So we can differentiate a with respect to r. So that is dA over dr, right? D by dr of 100 pi by r plus d by dr of 2 pi r square 100 pi will come out. D by dr of r raised to minus 1. This 2 pi is constant. Differentiation of r square is 2r. And of the r with respect to r, everything is fine. So it is not the case of implicit differentiation. It's regular, simple differentiation. N r raised to minus 1 minus 1. And here we have already done the differentiation. So 4 pi r. Good. So I have dA by dr is equal to negative 100 pi over r square plus 4 pi r. Now our regular process. For the maximum or minimum value of a, this dA by dr is equal to 0. And then from there we will get the value of r and the done. Done. So let us write it. For the maximum or minimum value of a, its first derivative is equal to 0. In our question, we are interested in the minimum value of area. So that is why I kept the maximum in the bracket. You can avoid writing this if you don't want to write. So negative 100 pi by r square plus 4 pi r is equal to 0. So 4 pi r is equal to 100 pi by r square. Pi cancelled. So I get r cube is equal to 25. So r is the cube root of 25. And again, you don't need to prove that your solution gives the minimum surface area. So we accept the result that this r gives the minimum surface area. Suppose that if they ask for the height, if they will ask for the height for which the surface area is minimum, then what you should do, you can use the obtained r. For this r, surface area is minimum. So I can use that r over here and I can get the value of h for which the surface area is minimum. And they're done. But if the question is asking for h and you try to eliminate r is present at two different places, then you have to plug in the value of r from here at two different places. So it will be a huge expression and the algebra becomes little difficult, but it can be done. So what decision I have taken nicely over here, I want r. So I try to keep r in front of us. That's the plan. But if they ask for h, it is not the compulsion that you have to keep h over here. No, that's fine. We obtained r, right? Use this r over here, you will get h. That is fine. So, what is the wise decision? Try to eliminate the variable which is easier to eliminate. Here h is present at one place only, so to eliminate it is an easy task. So I eliminated that. I did not eliminate r because it is present at two places. So take a good decision. That's all for the day. Practice these questions. See you then. Bye bye.